Here's an example of a program where we're going to be using a class. And a class is kind of a difficult concept, so just think of this as an introduction to the idea of a class. Um, we're going to look at some more sophisticated ways to do classes later in the course. Oftentimes when you're programming a large program, the class will even go in a different file, and you'll also create a header file. But since this is a short program and this is just an introduction to the idea, we're going to keep everything together just in one program. In addition, I wanted to show a couple different ways that you could handle using something that functions as a constant, or if you need to define a constant. So we're going to be working with a circle, so we like to have pi defined, and pi is not a predefined in C++. So you can create something that kind of looks like a constant by using a # define. So right here we have # define space pi space, and then the value that we're going to use for pi. So anytime you have a # define in your program, it looks for the character sequence that you have after the define, and it just basically does a find and replace with that character sequence and replaces it with whatever you have after that sequence. So this would do a find and replace on our program, and anywhere we have lowercase pi in our program, it would replace the pi with the number 3.14159, etc. before it goes through and builds and compiles. The other way that you could do a constant is you can define a type, so in this case it's a double, and then you just put const, which just means constant, in front of the type declaration. And that means if your program tries to change it later, so if your program tries to reset the value to something else, it won't allow it. Notice the format's a little bit different though, because it's still a type double, so it would be double pi, and then you could use an equal sign and then give it the value and then end with the semicolon, or you could do the parentheses around the value, in other words like this, and end with the semicolon. Let me just change it back to an equal sign. Notice with the # define though, it's not a C++ statement because it's a preprocessor directive, and so it doesn't end with the semicolon. Looking at the rest of this program, we're going to do some input-output. So we have # include IOStream, and we're going to work with strings. So we have # include string, and we're going to use some set w, so the set width. So we're going to use the # include IOmanip. So here's our class prototype, and this really shows you what the class does. So think of the class as a way to group a bunch of things together into what's called an object. So the object is going to be the circle, and the things that we're grouping together into the object are going to be some variables. So we have float, radius, area, and perimeter, and then also some functions. So we've got what's called a constructor here, which is kind of a type of function, although a constructor won't produce any, there's nothing that's returned when you run a constructor. So that's not an int or a float or anything in front of the constructor ever. And then we have some just regular kind of functions. We call them members of the classes. And they're going to have things that they return. So they're going to return, this one's going to return a float. So get area is going to return the area as a float. Get perimeter is going to return the perimeter as a float. And when we build a class, there may be certain things that we want to keep hidden from the rest of the program, so that the rest of the program doesn't inadvertently accidentally change them. But then there's also things like these functions that we want to have the rest of the program be able to interact with. So in this case, if we want the rest of the program to interact with it, it's going to be under public. If we want to keep it hidden from the rest of the program, we're going to put it under private. And there's some additional complexity with classes, but we'll talk about that later. This is called a class prototype. So this just defines the class and all the variables that we're going to be using in private or public, and all the functions that we're going to be using as private or public. And so since it's a prototype, it needs a semicolon at the end of the close brace. And then classes look a little bit like functions, right? So it says class and then the name of the class, open brace, and then you've got the close brace. But at the same time, they don't look completely like functions, because note that there's no open close parentheses after circle here. And class is a keyword. So the class prototype sets everything up in terms of kind of what's in the class, but then we have to put the code in it that's going to enable the class to work. So our enabling code is down here, and anytime we do the enabling code outside of the class prototype, we have to show that it comes from the class. So our class name is circle. So just like when we're using cout, we're going to do std : cout. This way, when we're working with our class, we're going to scope it back to our class. So it's class circle, so it's going to be circle : and then the name of the constructor or the member function of the class. So this is our constructor circle. So circle goes here, and then void just means it's not going to be receiving anything. So this one, since it doesn't take anything, is called our default constructor, and it sets up a default case. So in the context of a circle, maybe the default case would be a radius of 1, and then it goes ahead and it calculates the area and goes ahead and calculates the perimeter. So area would be pi r squared, and then perimeter would be 2 pi r. We can also do what's called a parameterized constructor, so we can send the class a value or a series of values and use that to initialize the class. So in this case, we're getting a value for the radius here that we're going to store in rad. We need some kind of temporary storage to place it in, and then we'll say radius is equal to rad. Now notice that radius is one of these private variables up here, so this is keeping that value then in the permanent storage location radius. And then again, we'll calculate area and perimeter. Notice that they're defined up here. Notice with both of these constructors, you have the open brace, the instructions, and then the close brace, and then the same thing here, open brace, close brace. Now we need to define the code that's going to do get area and then get perimeter. So get area is returning a float, so that's why it has float in front of it, but we need to scope it back to circle, so it would be circle : and then get underscore area, and then inside the parentheses you could leave it open, just empty, or you could type in the keyword void. And then there's open and close parentheses here, and then it's going to return area. Area is the same value that we calculated here, and again, it's that same value that's in this permanent private storage now of our class. Get perimeter is going to look very similar, float, circle : get underscore perimeter void, and then the open close curvy braces, and that's going to say return perimeter, semicolon. So let's see how we would now interact with the class inside main or inside another function. So here's our int main. So let's declare a couple variables in main, because we're going to want to hold the radius, maybe the area, and the perimeter. So we have float r, a, and p, semicolon. We're going to want to ask the user their name. So we've got std : string user underscore name, semicolon. And then we're going to do this input output. So we'll say welcome. We'll prompt the user for their name. We'll use the cn statement to read it into username. Then we'll print out a welcome. We'll use the name that we just read and print it out again. And then we'll prompt the user for radius, and we'll read that in with the cn statement. So here's how we're going to use our constructor. So our constructor is basically kind of a template of this idea of a circle. So we're going to say circle in front because now we've defined circle up there as our class. And then now we have a specific circle that we're creating. So we're going to create def underscore circle, and that's going to be a default circle. We want to use a default constructor. So don't pass it anything. If it's not passed anything, then when your program executes, it goes back up there, it looks at the class, and it says, hey, do I have a function where I'm not passed anything? And sure enough, that's our default constructor. And then it comes down here and does these sets of calculations. So it's going to set radius equal to 0, calculate area and perimeter. So let's go back down to our program. Now let's look at how we could use that class if we're going to send it a radius. So this would be the same circle because that's defined above, space, whatever you want to call this new circle. So I used my underscore circle, and then open parentheses, and then that value that you're going to pass it in close parentheses. Let's set up our formatting. So let's do 3 digits after the decimal. So we'll do a cout. Remember that we're going to do a fixed. And once we do a fixed, then set precision has the function of displaying digits after the decimal. Without the fixed, remember the set precision is going to give you the total number of digits before or after the decimal. And then we're going to then print it out. So let's say, okay, that's great, but how do we get the stuff back out of the class? So this is the format that you use to run the functions that are in the class. You use the name of the specific object that you created. So we created an object called myCircle. That was the one that had the radius that we typed in. And then a period separator, and then the name of the function that's part of the class. So get underscore area. And that function, C++ needs to know that it's a function, so we do open close parentheses on it, but we don't put anything in the parentheses. And then same thing for get parameter, myCircle dot get parameter open close parentheses. And then let's look at how we would get something out of the default circle that we created above. So its radius was 1, so I'm just going to print that out as a literal. So I just typed in 1.0. And then def circle dot get area. It's the same format that we use there, open close parentheses and the open close parentheses. So let me show you one little thing before we run this program. So one little just kind of weirdness of C++ with when you're using the default constructor, you might be tempted to say, well, a constructor kind of looks like a function. It sort of acts like a function, so walks like a duck, quacks like a duck. It must be a duck. But notice that that constructor is a little bit different than a function. So when you're using the default constructor, there is no open close parentheses, versus when you're using a function, there is an open close parentheses on it. Notice when you're using the parameterized constructor and you're sending it a parameter, then it looks exactly like you're using a function, except that the open close parentheses goes on the name for the specific instance of a class. So let's run it. So we're right here, it's wanting to know our name. And then it wants the radius of our circle. So we're right here, please enter the radius of the circle. Now it created the 2 instances of our class. It set the format flag and the precision, and now it's printing it out in these 2 data tables. So we've got the first one, a radius of 2.5, and there's our area, and there's our perimeter, and then for our default circle, there's our radius, and there's our area, and there's our perimeter. So with classes, it's you'll notice a couple things when you're first getting started programming. It's made your program a lot more complicated. That's usually the first thing that folks notice. And you're absolutely right. It made your program a lot more complicated, because if you had just put the equation in here, or even if you had just used some functions up here, maybe called the functions, that would have made your program so much simpler. So then you might say, well, why would I ever want to use a class? A class winds up being a really important and powerful concept in C++, and let's look at what it did for us other than making our program more complicated. So what it allowed us to do was it allowed us to package this code up into a module. So if we ever need to use, for Circle, we probably don't need to use it again. But let's say that you're writing a game, and maybe you have an enemy that you're creating. You could do class enemy, and then you could use that same enemy over and over and over again in a bunch of different games, because it basically took everything that was important to this idea of enemy and it packaged it all together. So that idea of really enhancing your code reusability is an important part of using a class. The second thing that it did is, just like a function, it took all this really detailed stuff and it pulled it outside of main. So it allowed you to focus in main more on the important parts, the big ideas, without having to get too bogged down into the details, and then you could write the details later in your class. And then probably the most important aspect of using a class is that oftentimes if you're programming for a company, you'll be working with a lot of folks on a single program, and so you can have an initial meeting and agree on the types of things that you need to create, the types of objects that you need to create, and define what you need them to do and what the functions are going to need to do. And then 5 different people then can go and program 5 different classes. And then when you're putting that together, it's very easy to put it together when it's programmed that way. If you had 5 different people programming 5 different things, and now you've got to somehow squeeze all of those 5 things together in main, and if 2 programmers accidentally use the same variable names, that creates a problem. You're going to have code that's going to be a lot more difficult to combine, a lot more difficult to maintain. So those are some of the benefits of using a class. But absolutely, if you say class just made a simple program a lot more complicated, it certainly does do that, but there are many benefits, especially as you go into writing more and more complicated programs. So hopefully this gives you kind of a brief introduction to class, and then we'll continue working on that concept kind of throughout the course. Thanks for watching.